Now we're ready to start creating the array that we're going to assign. We're going to flatten all of these polygons out onto, and that's really not unlike what we had done when we made the ceiling plane array of grids, when we were doing the different lengths of panels. So, but this is really kind of almost a separate activity, and we're going to start with a couple of number sliders. So I'm going to go slider. And I'm going to just set these so they have some basic, I'm going to make sure the step is 1. Let me zoom in here a little bit so that they're all the same. And I'll make this go to maybe 50 instead of 100. I'll close that off. And I will just duplicate these a couple of times. Because we need 3 of them. Well, these are going to allow us to control how many points we have, how far apart the points are, and then how far the whole array is from the original object, because we're all working in this kind of similar, the common space here. So the first thing I'm going to do is rename this one offset of array. The next one I'll call the number of panel spaces. And remember, this is always important so that you know what you're going to be able to manipulate. And then the other thing is we could have those points very close together and all of the polygons would overlap. So we want to make this idea of having a spacer. So this will be panel spacing. And we'll put these together with a little math, and hopefully this will become apparent here relatively quickly. So the first thing we need to do is obviously, if we have a number of panel spaces 10, if I put 10, I just get 10 out of here. What we really need to do is have 10 different numbers, so dimensions. So I'm going to use a code block to create what's called an array. So once again, a code block. That's just a place for, I don't know why that doesn't show up right away. And we're going to need another one, so I'm going to just copy and paste, sorry. So I don't have to do that in a minute. And in this first code block, I'm going to use what's called a series. I don't know if we've done this before. I'm going to go from 0, ... to x. And when I do and click off of that, I get an input of an x, and that'll give me a chance for an output. So I'll put this in here. I'll move the slider up a little bit, and then let's see what kind of numbers we have. So I have 10 points, and that gives us a list from 0 to 10 of numbers that go from 0 to 10. 0, so we have, something doesn't seem quite right there, but I'm not exactly sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we actually have 11 elements because 0 is the first one. Okay, so that's the way we create our arrays. And then if we wanted to just actually visualize those arrays, we can do points by coordinates. You notice this all of a sudden showed this point up here. So if I feed this in, let's say to the x, once again, you can now see that start of the array down here at the bottom. And if we do it in both directions, I stick the y in, it now is moving on that angle. And that's a little hard to see. I want to rotate around. This is a very common issue with creating these kind of arrays. So it looks like we have only 10 units, but we fed 10 in for both of them. And that's because of the way it's doing the math or the geometry. It's only making 11 elements. But we have a way of controlling that. It's called lacing. And instead of having it be the shortest or the longest product, we want the cross product. The minute we do that, now we get an array of 11 by 11. So now we have this idea of being able to create that array. But now we want to be, once again, like I said, have some ability to manipulate it. So I want to do create some kind of spacing. So I'm going to use this code block again. And this time I'm going to input, let's see, we'll do number. And that's just a word. It's not, it doesn't have any significance. It's just to us. And then space. Oops, time space. And I'll just click off of that, and you see we have now this nice labeled input. I've got number times space. So I'm going to feed in the numbers and then multiply it by the panel spacing. And then now I'm going to feed that number into the X and the Y. And now when I move this slider, you notice how the array gets much further spaced apart. And I'll turn down the number of panel spaces so it isn't so off the screen, so to speak. Okay, now the only other problem we have is that idea of offset. Our array is sitting right underneath what we're already creating as a model. It's kind of getting in the way. So what I want to do is to be able to move that in probably, I guess, what you would call a global way. So I'm going to just add an offset value to an X. So once again, I'm going to use a code block. And I'll just do math X times Y. I could do original points. I'm afraid to put a space in there. Original points times offset. All right, and that's a little more descriptive. So now we're going to feed in those original points, or numbers, should I say, and then we're going to feed in that offset. And then we're going to feed both of these numbers once again into at least, let me see how I've done that, at least into the Y. And now if I move my slider, I have the ability to control that kind of an offset for where it sits. And I guess I could feed that also into the X. And now I could just kind of move it in a kind of a diagonal way. And then I'll just bring this array down so they're not spaced so far apart. All right, so now we have the complete way to manipulate that new points by coordinates. And what we want to do now is we have a new set of points. We want to transfer that into a coordinate system, just as we did with the original geometry, and it's called coordinate system by origin. I think that's dot by origin. So you import a coordinate. It's the opposite way around. I want it to go the other way. I guess I have to type in a little bit by origin. Input a point, and out comes the coordinate system. So if you didn't, if you didn't see that, you'll have to rewind the tape. All right, so once again, I plug in that coordinate system, and notice now we get these colored indications of X, Y, and Z axes. So now we have that new coordinate system, and really quickly here, all we have to do now is plug that new coordinate system in here, and now all our polygons are moved off into that, reappearing in that flat plane that we'll be able to dimension and manipulate to create, ideas about fabrication drawings. And you'll notice we have too many of them. I'm going to show you next how to clear that up, because it has to do with I'm feeding in too many awkward lists, so to speak. I need what's called flattening of them. But we can do a couple of things here. The one thing we can do is we can offset that array to get it out of the, oops. I've got something wrong with my math here because my panel spacing and my array spacing are kind of hooked together. Let me see what I did wrong here. I'll just pause, troubleshoot it, and pick it back up again. So the mistake I made was I was actually multiplying the offset instead of just adding in. So the offset dimension, so now if you look, if I do the offset of the array, I'm just moving it in one axis in order to just get it away from the object. I could move it in two, but I actually went back and grabbed the code block and left it in the z-axis, and I'm only manipulating the offset in the x-axis. And conversely, if you wanted to do it the other way around, obviously we just switch these back and forth. And now you can control moving them up and down. And I'll just switch this back. So the next thing, like I said, I want to clear up is why we have too many of these. So I have to figure out where in the list we need to flatten it, and I'll troubleshoot that, and then we'll pick that up in the next clip.